Hello and welcome to our video on linear regression using the least squares regression line. Now in the past you may have, maybe in science in year 7 and 8, you may have drawn a scatter plot like the one we've got here of data from an experiment that you conducted, and you might have been asked to draw a line of best fit into the data. So that would be where you get yourself a ruler and you find a line that has an equal number of data points on the top of the line and an equal number of data points on the bottom of the line. I'm going to try and draw one without my ruler. It might look something like this. And here you've got 1, 2, 3, 4 on the top of the line, 1, 2, 3 on the bottom of the line. So I would move my ruler slightly to make that a better line and best fit. Do not do this in the exam. They'll never ask for a line of best fit, so don't ever get your ruler out and try and fit a line of best fit to where you think the data points will go in there. The reason is it's not a very accurate way of finding a line that fits the data. Different people might get slightly different lines. And we're looking for accuracy in senior maths, and they will never ask you to do this type of a regression line. The type of regression line that you will need to find is called a least squares regression line. I've just put a reminder here that you will never ever be asked to draw a line of best fit, so don't think that that's what they're asking for. If they say draw a least squares regression line, they're asking for a completely separate line. The least squares regression line works best when we've got no outliers, and what we do is we take our data points. I've got some here for you. I'll put them in red. 1, 2, 3. So imagine I just had those data points plotted on a scatter graph, and what we do is we find a regression line and we calculate the distance of each point away from the regression line. So this is going to be a positive distance because it's higher, the point is higher. This is negative because the point's lower than the line, and this is going to be positive because the point's above the line. These distances of each point from the line are called the residuals, and you need to know that word, residuals. So they are, in my example there, D1, D2, D3. It's just the distance of the point from the regression line that you've drawn. The least squares regression line that we're learning about aims to keep the sum of the squares of the residuals as low as possible. The sum of the squares of the residuals. There's a few words in there. The sum means we're going to add them all up, and the squares of the residuals means we just take these residual distances and square them, so multiply them by themselves. So I've got a little formula written down here. We're looking for D1 squared, so this value squared, plus, the plus is the sum part, plus D2 squared, plus D3 squared. And we're aiming to make that the smallest value that we possibly can. If we can do that, then we'll get a line that is the least squares regression line, and it's the most accurate that we can find. So this is a more accurate way of finding a regression line than drawing your own line of best fit and kind of guessing whether you're in between all the points, exactly halfway in between all the points. The reason the values are squared here is because, remember, we said this is a positive distance, this one is a negative distance, this one is a positive distance. So what we're trying to do is even out the data on each side of the line to try and get it to 0. So if you square a negative number, it makes a positive number. And if you square a positive number, it will make a positive number. So we're trying to make that if we add up all the differences, we're trying to make it the smallest that we possibly can. Assumptions when you're using a least squares regression line: you need to make sure your data is numerical. You wouldn't be drawing a scatter graph or a scatter plot if you didn't have numerical data, so hopefully that's not even an issue. You need to make sure that the association is linear. We haven't looked at other associations yet, but if it's a non-linear association, you cannot use the least squares regression line. And like I said up here, you need to make sure that there are no clear outliers in your data. There are 3 methods to calculate the least squares regression line. The first one is trial and error, where you basically draw a line, calculate all the residuals, see what they all square to, then draw another line, calculate the residuals, see what they all squared to. You might do that 4 or 5 times, and then you choose the least possible value, and that would be the best line that you have found. Not the best idea. Number 1, takes forever to calculate all those residuals. Second point is that you've only chosen, say, 5 or however many you choose, and there might be an even better line that you haven't calculated the residuals for. So we don't tend to use trial and error, but you do need to know how the formulas work. That's why I've taken you through this example. These are the 2 methods we're going to use. The first one is to use when you're giving summary statistics. So when you're given X bar, Y bar, standard deviation of X and standard deviation of Y, things like that, then you can use the formula that will be in another video and solve it by hand, and you'll be expected to know how to do that. If you are given the raw data, so you're just given a table of values, then you can enter that and use your CAS, which will be on a further video. Thanks for watching this video.